Hi Calculus. So we are going to calculate the average velocity of a ball in flight. A ball, imagine it held at a certain height and then tossed up into the air, straight up in the air until it comes down and hits the ground. And this is a graph of us tossing the ball up, and we're interested in its exact velocity at the time 0.8. So 0.8 seconds into its flight, when it's 63.36 feet above the ground, what is its velocity? And this is going to first talk about average velocity. And so this was our warm-up problem for Monday. Calculate the average velocity on the interval from 0.4 seconds to 0.8 seconds for a ball with this position function. And the position function is s of t equals 64 minus 16 times the quantity t minus 1 squared. And this, by position, we mean its height in feet above the ground. So we figured that we could draw a secant line that connected those 2 points. So this is when time is 0.4 seconds, and this is when time is 0.8 seconds. And we talked about, well, how could we calculate the average velocity between these 2 points to kind of, start getting closer to this instantaneous velocity. But the average velocity is change in distance over change in time. So as you can see on this graph, the change in distance is from this y value, 58.24, up to this y value of 63.36. That's the change in y, change in distance. So y2 minus y1. And the change in time is from 0.4 seconds to 0.8 seconds. So x2 minus x1, so 0.4 seconds. And that left us, if we zoom in, we get a nice closer look at this secant line. And we're finding the change in distance divided by the change in time, which will actually give us the change in y divided by the change in x, or the slope of this secant line. Right? So that's actually what the average velocity is. The change in distance over change in time is, when we have a graph of a position function, the change in y over change in x. So average velocity in this case is the same thing as the slope of our function. And here's a formula. So average velocity on the interval from a to b equals s of b minus s of a over b minus a. So think of this as, the x value b plugged into the function, and it's the y value for when x equals b. So it's y2 minus the y value when x equals a. So take the value a and plug it into the function, and what do you get for the y value? It's s of a. So s of b minus s of a is y2 minus y1, and x2 minus x1. So this is the change in y over the change in x, or the change in distance over the change in time, average velocity. And when we plug in the numbers, we get this, and we can crunch the numbers to calculate that the average velocity between 0.4 seconds and 0.8 seconds for this ball in flight is 12.8 feet per second. But what is the instantaneous velocity? What is the velocity of that ball exactly when time equals 0.8? And that we're going to get into in the next video. So this showed us that average velocity is the slope of that secant line.